Environment abstraction. The environment interface is an abstraction integrated in the container that models two key aspects of the application environment: profiles and properties. A profile is a named, logical group of bin definitions to be registered with the container only if the given profile is active. Beans may be assigned to a profile whether defined in XML or with annotations. The role of the environment object with relation to profiles is in determining which profiles, if any, are currently active, and which profiles, if any, should be active by default. Properties play an important role in almost all applications and may originate from a variety of sources: properties files, JVM system properties, system environment variables, JNDI, servlet context parameters, ad hoc properties objects, map objects, and so on. The role of the environment object with relation to properties is to provide the user with a convenient service interface for configuring property sources and resolving properties from them. Bin definition profiles. Bin definition profiles provide a mechanism in the core container that allows for registration of different beans in different environments. The word environment can mean different things to different users, and this feature can help with many use cases, including 1. Working against an in-memory data source in development versus looking up that same data source from JNDI when in QA or production. 2. Registering monitoring infrastructure only when deploying an application into a performance environment. 3. Registering customized implementations of beans for customer A versus customer B deployments. Consider the first use case in a practical application that requires a data source. In a test environment, the configuration might resemble the following. At bin public data source, return new embedded database builder set type embedded database type.hsql add script my schema.sql add script my test data.sql build. Now consider how this application can be deployed into a QA or production environment, assuming that the data source for the application is registered with the production application server's JNDI directory. Our data source bin now looks like the following listing. At bin destroy method equals public data source throws exception context ctx equals new initial context return data source ctx.lookup java comp/env/jdbc/data source. The problem is how to switch between using these two variations based on the current environment. Over time, Spring users have devised a number of ways to get this done, usually relying on a combination of system environment variables and XML import statements containing $placeholder tokens that resolve to the correct configuration file path depending on the value of an environment variable. Bin definition profiles is a core container feature that provides a solution to this problem. If we generalize the use case shown in the preceding example of environment-specific bin definitions, we end up with the need to register certain bin definitions in certain contexts but not in others. You could say that you want to register a certain profile of bin definitions in situation A and a different profile in situation B. We start by updating our configuration to reflect this need. Using @profile. The @profile annotation lets you indicate that a component is eligible for registration when one or more specified profiles are active. Using our preceding example, we can rewrite the data source configuration as follows. @configuration. @profile development, public class standalone, data, config. @bin. Public data source, return new embedded database builder set type embedded database type.hsql add script class path com/bank/config/sql/schema.sql add script class path com/bank/config/sql/testdata.sql build. @configuration. @profile production, public class JND, data, config. @bin destroy method equals public data source throws exception, context ctx equals new initial context, return, data source, ctx.lookup java comp/env/jdbc/data source. @bin destroy method equals disables default destroy method inference. As mentioned earlier, with @bin methods, you typically choose to use programmatic JNDI lookups by using either Spring's JND template/JND locator delegate helpers or the straight JNDI initial context usage shown earlier, but not the JND object factory bin variant, which would force you to declare the return type as the factory bin type. The profile string may contain a simple profile name, for example, production, or a profile expression. A profile expression allows for more complicated profile logic to be expressed, for example, production and US East. The following operators are supported in profile expressions. You cannot mix the and operators without using parentheses. For example, production and US East, EU Central is not a valid expression. It must be expressed as production and US East, EU Central. You can use @profile as a meta-annotation for the purpose of creating a custom composed annotation. The following example defines a custom @production annotation that you can use as a drop-in replacement for @profile production. @target element type @retention policy.runtime @profile production, public @interface production. If a @configuration class is marked with @profile, all of the @bin methods and @import annotations associated with that class are bypassed unless one or more of the specified profiles are active. If a @component or @configuration class is marked with @profile P1, P2, that class is not registered or processed unless profiles P1 or P2 have been activated. If a given profile is prefixed with the not operator, the annotated element is registered only if the profile is not active. For example, given @profile P1, P2, registration will occur if profile P1 is active or if profile P2 is not active. @profile can also be declared at the method level to include only one particular bin of a configuration class, for example, for alternative variants of a particular bin, as the following example shows. @configuration. Public class app. Config. @bin data source. @profile development. Public data source standalone data source. Return new embedded database builder set type embedded database type.hsql add script class path com/bank/config/sql/schema.sql add script class path com/bank/config/sql/testdata.sql build. @bin data source. @profile production. Public data source JND data source throws exception, context ctx equals new initial context, return, data source, ctx.lookup java comp/env/jdbc/data source. The standalone data source method is available only in the development profile. The JND data source method is available only in the production profile. With @profile on @bin methods, a special scenario may apply, in the case of overloaded @bin methods of the same Java method name, analogous to constructor overloading. A @profile condition needs to be consistently declared on all overloaded methods. If the conditions are inconsistent, only the condition on the first declaration among the overloaded methods matters. Therefore, @profile cannot be used to select an overloaded method with a particular argument signature over another. Resolution between all factory methods for the same bin follows Spring's constructor resolution algorithm at creation time. If you want to define alternative beans with different profile conditions, use distinct Java method names that point to the same bin name by using the @bin name attribute, as shown in the preceding example. If the argument signatures are all the same, for example, all of the variants have no arg factory methods, This is the only way to represent such an arrangement in a valid Java class in the first place, since there can only be one method of a particular name and argument signature. XML bin definition profiles. The XML counterpart is the profile attribute of the beans element. Our preceding sample configuration can be rewritten in two XML files, as follows. It is also possible to avoid that split and nest beans elements within the same file, as the following example shows. The Spring bin.xsd has been constrained to allow such elements only as the last ones in the file. This should help provide flexibility without incurring clutter in the XML files. The XML counterpart does not support the profile expressions described earlier. It is possible, however, to negate a profile by using the operator. It is also possible to apply a logical AND by nesting the profiles, as the following example shows. In the preceding example, the data source bin is exposed if both the production and us-east profiles are active. Activating a profile. Now that we have updated our configuration, we still need to instruct Spring which profile is active. If we started our sample application right now, we would see a no such bin definition exception thrown, because the container could not find the Spring bin named data source. Activating a profile can be done in several ways, but the most straightforward is to do it programmatically against the Environment API, which is available through an application context. The following example shows how to do so. Annotation config application context CTX equals new annotation config application context ctx.getEnvironment. Set active profiles development ctx.register some config.class standalone data config.class jindy data config.class ctx.refresh. In addition, you can also declaratively activate profiles through the spring.profiles.active property, which may be specified through system environment variables, JVM system properties, servlet context parameters in web.xml, or even as an entry in JNDI, C property source abstraction. In integration tests, active profiles can be declared by using the @ActiveProfiles annotation in the Spring test module. See context configuration with environment profiles. Note that profiles are not an either-or proposition. You can activate multiple profiles at once. Programmatically, you can provide multiple profile names to the setActiveProfiles method, which accepts string vargs. The following example activates multiple profiles. ctx.getEnvironment. Set active profiles profile 1, profile 2. Declaratively, spring.profiles.active may accept a comma-separated list of profile names, as the following example shows. Default profile. The default profile represents the profile that is enabled if no profile is active. Consider the following example. At configuration. At profile default, public class default, data, config. At bin. Public data source, return new embedded database builder set type embedded database type.hsql add script class bath.com/bank/config/sql/schema.sql build. If no profile is active, the data source is created. You can see this as a way to provide a default definition for one or more beans. If any profile is enabled, the default profile does not apply. The name of the default profile is default. You can change the name of the default profile by using setDefaultProfiles on the environment or, declaratively, by using the spring.profiles.default property. Property source abstraction. Spring's environment abstraction provides search operations over a configurable hierarchy of property sources. Consider the following listing. Application context CTX equals new generic application context, environment env equals ctx.getEnvironment, Boolean contains my property equals env dot contains property my property, system.out.println does my environment contain the my property property? Plus contains my property. In the preceding snippet, we see a high-level way of asking Spring whether the my property property is defined for the current environment. To answer this question, the environment object performs a search over a set of property source objects. A property source is a simple abstraction over any source of key-value pairs, and Spring's standard environment is configured with two property source objects, one representing the set of JVM system properties, system.getProperties, and one representing the set of system environment variables, system.getInf. These default property sources are present for standard environment, for use in standalone applications. Standard servlet environment is populated with additional default property sources including servlet config, servlet context parameters, and a JNDI property source if JNDI is available. Concretely, when you use the standard environment, the call to env contains property my property returns true if a my property system property or my property environment variable is present at runtime. The search performed is hierarchical. By default, system properties have precedence over environment variables. So, if the my property property happens to be set in both places during a call to env.getProperty my property, the system property value wins and is returned. Note that property values are not merged but rather completely overridden by a preceding entry. For a common standard servlet environment, the full hierarchy is as follows, with the highest precedence entries at the top. 1. Servlet config parameters, if applicable, for example, in case of a dispatcher servlet context. 2. Servlet context parameters, web.xml context param entries. 3. JNDI environment variables, java comp/env/entries. 4. JVM system properties, D command line arguments. 5. JVM system environment, operating system environment variables. Most importantly, the entire mechanism is configurable. Perhaps you have a custom source of properties that you want to integrate into this search. To do so, implement and instantiate your own property source and add it to the set of property sources for the current environment. The following example shows how to do so. Configurable application context CTX equals new generic application context, mutable property sources equals CTX.getEnvironment. Get property sources add first new my property source. In the preceding code, my property source has been added with highest precedence in the search. If it contains a my property property, the property is detected and returned, in favor of any my property property in any other property source. The Mutable Property Sources API exposes a number of methods that allow for precise manipulation of the set of property sources. Using @PropertySource. The @PropertySource annotation provides a convenient and declarative mechanism for adding a property source to Spring's environment. Given a file called app.properties that contains the key value pair testbin.name equals my testbin, the following @configuration class uses @PropertySource in such a way that a call to testbin.getName returns my testbin. @configuration. @PropertySource classpath :com/myco/app.properties, public class app, config. @AutoWired. Environment env. @bin. Public testbin testbin equals new testbin, testbin.setName env.getProperty testbin.name, return test bin. Any $, placeholders present in a @PropertySource resource location are resolved against the set of property sources already registered against the environment, as the following example shows. @configuration. At property source class path $com/my.placeholder default /path/app.properties public class app config. At autowired environment env. At bin public test bin equals new test bin testbin.setName env.get property testbin.name return test bin. Assuming that my .placeholder is present in one of the property sources already registered, for example, system properties or environment variables, the placeholder is resolved to the corresponding value. If not, then default/path is used as a default. If no default is specified and a property cannot be resolved, an illegal argument exception is thrown. At property source can be used as a repeatable annotation. At property source may also be used as a meta annotation to create custom composed annotations with attribute overrides. Placeholder resolution in statements. Historically, the value of placeholders in elements could be resolved only against JVM system properties or environment variables. This is no longer the case. Because the environment abstraction is integrated throughout the container, it is easy to route resolution of placeholders through it. This means that you may configure the resolution process in any way you like. You can change the precedence of searching through system properties and environment variables or remove them entirely. You can also add your own property sources to the mix, as appropriate. Concretely, the following statement works regardless of where the customer property is defined, as long as it is available in the environment. Registering a LoadTimeWeaver. Once configured for the application context, any bin within that application context may implement LoadTimeWeaver aware, thereby receiving a reference to the LoadTimeWeaver instance. This is particularly useful in combination with Spring's JPA support where load time weaving may be necessary for JPA class transformation. Consult the local container entity manager factory bin Java doc for more detail. For more on Aspect load time weaving, see load time weaving with Aspect in the Spring framework. Additional capabilities of the application context. As discussed in the chapter introduction, the org.springframework.beans.factory package provides basic functionality for managing and manipulating beans, including in a programmatic way. The org.springframework.context package adds the application context interface, which extends the BeanFactory interface, in addition to extending other interfaces to provide additional functionality in a more application framework-oriented style. Many people use the application context in a completely declarative fashion, not even creating it programmatically, but instead relying on support classes such as Context Loader to automatically instantiate an application context as part of the normal startup process of a Jakarta EE web application. To enhance BeanFactory functionality in a more framework-oriented style, the context package also provides the following functionality. 1. Access to messages in internationalization style, through the message source interface. 2. Access to resources, such as URLs and files, through the resource loader interface. 3. Event publication, namely to beans that implement the application listener interface, through the use of the application event publisher interface. 4. Loading of multiple, hierarchical, contexts, letting each be focused on one particular layer, such as the web layer of an application, through the hierarchical BeanFactory interface. Internationalization using message source. The application context interface extends an interface called message source and, therefore, provides internationalization functionality. Spring also provides the hierarchical message source interface, which can resolve messages hierarchically. Together, these interfaces provide the foundation upon which Spring affects message resolution. The methods defined on these interfaces include 1. String get message string code, object, args, string default, locale lock, the basic method used to retrieve a message from the message source. When no message is found for the specified locale, the default message is used. Any arguments passed in become replacement values, using the message format functionality provided by the standard library. 2. String get message string code, object, args, locale lock, essentially the same as the previous method but with one difference: no default message can be specified. If the message cannot be found, a no such message exception is thrown. 3. String get message source resolvable, locale. All properties used in the preceding methods are also wrapped in a class named message source resolvable, which you can use with this method. When an application context is loaded, it automatically searches for a message source bin defined in the context. The bin must have the name message source. If such a bin is found, all calls to the preceding methods are delegated to the message source. If no message source is found, the application context attempts to find a parent containing a bin with the same name. If it does, it uses that bin as the message source. If the application context cannot find any source for messages, an empty delegating message source is instantiated in order to be able to accept calls to the methods defined above. Spring provides 3 message source implementations: resource bundle message source, reloadable resource bundle message source, and static message source. All of them implement hierarchical message source in order to do nested messaging. The static message source is rarely used but provides programmatic ways to add messages to the source. The following example shows resource, bundle, message, source. Beans bin I.d. equals message source class equals org.springframework.context.support.resource bundle message source greater than property name equals base names greater than list value format /value exceptions /value windows /value list property bin beans. The example assumes that you have 3 resource bundles called format, exceptions and windows defined in your class path. Any request to resolve a message is handled in the JDK standard way of resolving messages through resource bundle objects. For the purposes of the example, assume the contents of 2 of the above resource bundle files are as follows. The next example shows a program to run the message source functionality. Remember that all application context implementations are also message source implementations and so can be cast to the message source interface. Public static void main string, args, message source resources equals new class path XML application context beans.xml, string message equals resources.get message, null, default, locale.english. System.out.println message. The resulting output from the above program is as follows. To summarize, the message source is defined in a file called beans.xml, which exists at the root of your class path. The message source bin definition refers to a number of resource bundles through its basenames property. The 3 files that are passed in the list to the basenames property exist as files at the root of your class path and are called format.properties, exceptions.properties, and windows.properties, respectively. The next example shows arguments passed to the message lookup. These arguments are converted into string objects and inserted into placeholders in the lookup message. Less than. This message source is being used in a web application, greater than. org.springframework.context.support.resource, bundle, message, source. Less than, let's inject the above message source into this POJO, greater than. Public class example. Private message source messages. Public void set messages message source messages. This dot messages equals messages. Public void execute, string message equals this dot messages dot get message argument dot required, new object. User DAO, required, locale.english, system.out.println message. The resulting output from the invocation of the execute method is as follows. With regard to internationalization, Spring's various message source implementations follow the same locale resolution and fallback rules as the standard JDK resource bundle. In short, and continuing with the example message source defined previously, if you want to resolve messages against the British NGB locale, you would create files called format_n_gb.properties, exceptions_n_gb.properties, and windows_n_gb.properties, respectively. Typically, locale resolution is managed by the surrounding environment of the application. In the following example, the locale against which British messages are resolved is specified manually. Hash and exceptions_n_gb.properties. Argument.required equals a Begum lad. The 0 argument is required, I say, required. Public static void main final string, args. Message source resources equals new class path XML application context beans.xml, string message equals resources.get message argument.required, new object. User DAO, required, locale. UK, system.out.println message. The resulting output from the running of the above program is as follows. A Begum lad, the user DAO argument is required, I say, required. You can also use the message source aware interface to acquire a reference to any message source that has been defined. Any bin that is defined in an application context that implements the message source aware interface is injected with the application context's message source when the bin is created and configured. Because Spring's message source is based on Java's resource bundle, it does not merge bundles with the same base name, but will only use the first bundle found. Subsequent message bundles with the same base name are ignored. As an alternative to resource bundle message source, Spring provides a reloadable resource bundle message source class. This variant supports the same bundle file format, but is more flexible than the standard JDK-based resource bundle message source implementation. In particular, it allows for reading files from any Spring resource location, not only from the class path, and supports hot reloading of bundle property files, while efficiently caching them in between. See the reloadable resource bundle message source JavaDoc for details. Standard and custom events. Event handling in the application context is provided through the application event class and the application listener interface. If a bin that implements the application listener interface is deployed into the context, every time an application event gets published to the application context, that bin is notified. Essentially, this is the standard observer design pattern. As of Spring 4.2, the event infrastructure has been significantly improved and offers an annotation-based model as well as the ability to publish any arbitrary event, that is, an object that does not necessarily extend from application event. When such an object is published, we wrap it in an event for you. The following table describes the standard events that Spring provides. Context. Refreshed. Event. Published when the application context is initialized or refreshed, for example, by using the refresh method on the configurable application context interface. Here, initialized means that all beans are loaded, post-processor beans are detected and activated, singletons are pre-instantiated, and the application context object is ready for use. As long as the context has not been closed, a refresh can be triggered multiple times, provided that the chosen application context actually supports such hot refreshes. For example, XML Web Application Context supports hot refreshes, but generic application context does not. Context. Started. Event. Published when the application context is started by using the start method on the configurable application context interface. Here, started means that all lifecycle beans receive an explicit start signal. Typically, this signal is used to restart beans after an explicit stop, but it may also be used to start components that have not been configured for autostart, for example, components that have not already started on initialization. Context. Stopped. Event. Published when the application context is stopped by using the stop method on the configurable application context interface. Here, stopped means that all lifecycle beans receive an explicit stop signal. A stopped context may be restarted through a start call. Context. Closed. Event. Published when the application context is being closed by using the close method on the configurable application context interface or via a JVM shutdown hook. Here, closed means that all singleton beans will be destroyed. Once the context is closed, it reaches its end of life and cannot be refreshed or restarted. Request. Handled. Event. A web-specific event telling all beans that an HTTP request has been serviced. This event is published after the request is complete. This event is only applicable to web applications that use Spring's dispatcher. Servlet. Servlet. Request. Handled. Event. A subclass of request-handled event that adds servlet-specific context information. You can also create and publish your own custom events. The following example shows a simple class that extends Spring's application event base class. Public class blocked list event extends application event. Private final string address, private final string content. Public blocked list event object source, string address, string content. Supersource. This .address equals address, this .content equals content. / accessor and other methods. To publish a custom application event, call the publish event method on an application event publisher. Typically, this is done by creating a class that implements application event publisher aware and registering it as a Spring bin. The following example shows such a class. Public class email service implements application event publisher aware. Private list string blocked list private application event publisher publisher. Public void set blocked list list string blocked list. This blocked list equals blocked list. Public void set application event publisher publisher. This .publisher equals publisher. Public void send email string address, string content. If blocked list contains address, publisher.publish event new blocked list event this address, content, return. / send email. At configuration time, the Spring container detects that email service implements application event publisher aware and automatically calls set application event publisher. In reality, the parameter passed in is the Spring container itself. You are interacting with the application context through its application event publisher interface. To receive the custom application event, you can create a class that implements application listener and register it as a Spring bin. The following example shows such a class. Public class blocked list notifier implements application listener blocked list event. Private string notification address. Public void set notification address string notification address. This .notification address equals notification address. Public void on application event blocked list event / notify appropriate parties via notification address. Notice that application listener is generically parameterized with the type of your custom event, blocked list event in the preceding example. This means that the onApplication event method can remain type safe, avoiding any need for downcasting. You can register as many event listeners as you wish, but note that, by default, event listeners receive events synchronously. This means that the publish event method blocks until all listeners have finished processing the event. One advantage of this synchronous and single-threaded approach is that, when a listener receives an event, it operates inside the transaction context of the publisher if a transaction context is available. If another strategy for event publication becomes necessary, for example asynchronous event processing by default, see the Java doc for Spring's application event multicaster interface and simple application event multicaster implementation for configuration options which can be applied to a custom application event multicaster bin definition. In these cases, thread locals and logging context are not propagated for the event processing. See the @Event Listener Observability section for more information on observability concerns. The following example shows the bin definitions used to register and configure each of the classes above. Bin.d. equals email service class equals example.email service greater than property name equals blocked list greater than list value known.spammer at example.org/value known.hacker at example.org/value john.doe at example.org/value/list/property/bin. Bin.d. equals blocked list notifier class equals example.blocked list notifier greater than property name equals notification address value equals blocked list at example.org greater than /bin. Less than, optional, a custom application event multicaster definition greater than bin.d. equals application event multicaster class equals org.springframework.context.event.simple application event multicaster greater than property name equals task executor ref equals greater than property name equals error handler ref equals greater than /bin. Putting it all together, when the send email method of the email service bin is called, if there are any email messages that should be blocked, a custom event of type blocked list event is published. The blocked list notifier bin is registered as an application listener and receives the blocked list event, at which point it can notify appropriate parties. Spring's eventing mechanism is designed for simple communication between Spring beans within the same application context. However, for more sophisticated enterprise integration needs, the separately maintained Spring Integration project provides complete support for building lightweight, pattern-oriented, event-driven architectures that build upon the well-known Spring programming model. Annotation-based event listeners. You can register an event listener on any method of a managed bin by using the @Event Listener annotation. The blocked list notifier can be rewritten as follows. Public class blocked list notifier. Private string notification address. Public void set notification address string notification address. This .notification address equals notification address. @Event Listener. Public void process blocked list event event. / notify appropriate parties via notification address. The method's signature once again declares the event type to which it listens, but, this time, with a flexible name and without implementing a specific listener interface. The event type can also be narrowed through generics as long as the actual event type resolves your generic parameter in its implementation hierarchy. If your method should listen to several events or if you want to define it with no parameter at all, The event types can also be specified on the annotation itself. The following example shows how to do so. At event listener context started event.class, context refreshed event.class, public void handle context start, // It is also possible to add additional runtime filtering by using the condition attribute of the annotation that defines a SpEL expression, which should match to actually invoke the method for a particular event. The following example shows how a notifier can be rewritten to be invoked only if the content attribute of the event is equal to myEvent. At event listener condition equals #BL event.content equals myEvent, public void process blocked list event BL event, / notify appropriate parties via notification address. Each SpEL expression evaluates against a dedicated context. The following table lists the items made available to the context so that you can use them for conditional event processing. Event. Root object. The actual application. Event. #root.event or event. Arguments array. Root object. The arguments, as an object array, used to invoke the method. #root.args or args0, to access the first argument, etc. argument name. Evaluation context. The name of any of the method arguments. If, for some reason, the names are not available, for example, because there is no debug information in the compiled bytecode, individual arguments are also available using the #a <arg syntax where >arg stands for the argument index, starting from 0. #BL event or #A0, you can also use #P0 or #P less than #arg parameter notation as an alias. Note that #root.event gives you access to the underlying event, even if your method's signature actually refers to an arbitrary object that was published. If you need to publish an event as the result of processing another event, you can change the method's signature to return the event that should be published, as the following example shows. Public list update event handle blocked list event event. / notify appropriate parties via notification address and. This feature is not supported for asynchronous listeners. The handle blocked list event method publishes a new list update event for every blocked list event that it handles. If you need to publish several events, you can return a collection or an array of events instead. Asynchronous listeners. If you want a particular listener to process events asynchronously, you can reuse the regular @async support. The following example shows how to do so. / blocked list event is processed in a separate thread. Be aware of the following limitations when using asynchronous events. 1. If an asynchronous event listener throws an exception, it is not propagated to the caller. See async uncaught exception handler for more details. 2. Asynchronous event listener methods cannot publish a subsequent event by returning a value. If you need to publish another event as the result of the processing, inject an application event publisher to publish the event manually. 3. Thread locals and logging context are not propagated by default for the event processing. See the @event listener observability section for more information on observability concerns. Ordering listeners. If you need one listener to be invoked before another one, you can add the @order annotation to the method declaration, as the following example shows. / notify appropriate parties via notification address. Generic events. You can also use generics to further define the structure of your event. Consider using an entity-created event less than T where T is the type of the actual entity that got created. For example, you can create the following listener definition to receive only entity-created event for a person. Due to type erasure, This works only if the event that is fired resolves the generic parameters on which the event listener filters, that is, something like class person created event extends entity created event person. In certain circumstances, this may become quite tedious if all events follow the same structure, as should be the case for the event in the preceding example. In such a case, you can implement resolvable type provider to guide the framework beyond what the runtime environment provides. The following event shows how to do so. Public class entity created event less than t extends application event implements resolvable type provider. Public entity created event t entity super entity at override. Public resolvable type get resolvable type, return resolvable type. For class with generics get class, resolvable type. For instance get source. This works not only for application event but any arbitrary object that you send as an event. Finally, as with classic application listener implementations, the actual multicasting happens via a context-wide application event multicaster at runtime. By default, this is a simple application event multicaster with synchronous event publication in the caller thread. This can be replaced/customized through an application event multicaster bin definition, for example for processing all events asynchronously and/or for handling listener exceptions. At bin. Application event multicaster simple application event multicaster equals new simple application event multicaster.set task executor multicaster.set error handler return multicaster. Convenient access to low-level resources. For optimal usage and understanding of application contexts, you should familiarize yourself with Spring's resource abstraction, as described in Resources. An application context is a resource loader, which can be used to load resource objects. A resource is essentially a more feature-rich version of the JDK Java.NET URL class. In fact, the implementations of the resource wrap an instance of Java.NET URL, where appropriate. A resource can obtain low-level resources from almost any location in a transparent fashion, including from the class path, a file system location, anywhere describable with a standard URL, and some other variations. If the resource location string is a simple path without any special prefixes, where those resources come from is specific and appropriate to the actual application context type. You can configure a bin deployed into the application context to implement the special callback interface, resource loader aware, to be automatically called back at initialization time with the application context itself passed in as the resource loader. You can also expose properties of type resource to be used to access static resources. They are injected into it like any other properties. You can specify those resource properties as simple string paths and rely on automatic conversion from those text strings to actual resource objects when the bin is deployed. The location path or paths supplied to an application context constructor are actually resource strings and, in simple form, are treated appropriately according to the specific context implementation. For example, class path XML application context treats a simple location path as a class path location. You can also use location paths, resource strings, with special prefixes to force loading of definitions from the class path or a URL, regardless of the actual context type. Application startup tracking. The application context manages the lifecycle of Spring applications and provides a rich programming model around components. As a result, complex applications can have equally complex component graphs and startup phases. Tracking the application startup steps with specific metrics can help understand where time is being spent during the startup phase, but it can also be used as a way to better understand the context lifecycle as a whole. The abstract application context, and its subclasses, is instrumented with an application startup, which collects startup step data about various startup phases. 1. Application Context Lifecycle, Based Packages Scanning, Config Classes Management. 2. Beans Lifecycle, Instantiation, Smart Initialization, Post-Processing. 3. Application Events Processing. Here is an example of instrumentation in the annotation. Config, application, context, / create a startup step and start recording. Startup step scan packages equals get application startup. Start spring.context.based-packages.scan / add tagging information to the current step. Scan packages.tag packages greater than arrays.toString based packages / perform the actual phase we're instrumenting. This .scanner.scan base packages / end the current step. Scan packages.end. The application context is already instrumented with multiple steps. Once recorded, these startup steps can be collected, displayed and analyzed with specific tools. For a complete list of existing startup steps, you can check out the dedicated appendix section. The default application startup implementation is a no-op variant for minimal overhead. This means no metrics will be collected during application startup by default. Spring Framework ships with an implementation for tracking startup steps with Java Flight Recorder application startup. To use this variant, you must configure an instance of it to the application context as soon as it's been created. Developers can also use the application startup infrastructure if they're providing their own abstract application context subclass, or if they wish to collect more precise data. Application startup is meant to be only used during application startup and for the core container. This is by no means a replacement for Java profilers or metrics libraries like Micrometer. To start collecting custom startup step, components can either get the application startup instance from the application context directly, make their component implement application startup aware, or ask for the application startup type on any injection point. Developers should not use the Spring namespace when creating custom startup steps. This namespace is reserved for internal Spring usage and is subject to change. Convenient application context instantiation for web applications. You can create application context instances declaratively by using, for example, a context loader. Of course, you can also create application context instances programmatically by using one of the application context implementations. You can register an application context by using the context loader listener, as the following example shows. Context param name context config location / param name param value / web inf / DAO context.xml / web inf / application context.xml / param value / context param. Listener class org.springframework.web.context context loader listener class / listener. The listener inspects the context config location parameter. If the parameter does not exist, the listener uses /web inf / application context.xml as a default. When the parameter does exist, the listener separates the string by using predefined delimiters, comma, semicolon, and whitespace, and uses the values as locations where application contexts are searched. And style path patterns are supported as well. Examples are /web inf, context.xml, for all files with names that end with context.xml and that reside in the web inf directory, and /web inf context.xml, for all such files in any subdirectory of web inf. Deploying a Spring application context as a Jakarta ERA file. It is possible to deploy a Spring application context as a RAR file, encapsulating the context and all of its required bin classes and library jars in a Jakarta EE-RA deployment unit. This is the equivalent of bootstrapping a standalone application context, only hosted in Jakarta EE environment, being able to access the Jakarta EE server's facilities. RA deployment is a more natural alternative to a scenario of deploying a headless WAR file, in effect, a WAR file without any HTTP entry points that is used only for bootstrapping a Spring application context in a Jakarta EE environment. RA deployment is ideal for application contexts that do not need HTTP entry points but rather consist only of message endpoints and scheduled jobs. Beans in such a context can use application server resources such as the JTA Transaction Manager and JNDI-bound JDBC data source instances and JMS Connection Factory instances, and can also register with the platform's JMX server all through Spring's standard transaction management and JNDI and JMX support facilities. Application components can also interact with the application server's JCA Work Manager through Spring's Task Executor abstraction. See the Java doc of the Spring Context Resource Adapter class for the configuration details involved in RA deployment. For a simple deployment of a Spring application context as a Jakarta EE RA file, package all application classes into a RA file, which is a standard jar file with a different file extension. Add all required library jars into the root of the RA archive. Add a meta-inf/ra.xml deployment descriptor, as shown in the Java doc for Spring Context Resource Adapter, and the corresponding Spring XML bin definition files, typically meta-inf/applicationcontext.xml. Drop the resulting RA file into your application server's deployment directory. Such RA deployment units are usually self-contained. They do not expose components to the outside world, not even to other modules of the same application. Interaction with the RA-based application context usually occurs through JMS destinations that it shares with other modules. A RA-based application context may also, for example, schedule some jobs or react to new files in the file system, or the like. If it needs to allow synchronous access from the outside, it could, for example, export RMI endpoints, which may be used by other application modules on the same machine. The BeanFactory API. The BeanFactory API provides the underlying basis for Spring's IoC functionality. Its specific contracts are mostly used in integration with other parts of Spring and related third-party frameworks, and its default listable BeanFactory implementation is a key delegate within the higher-level generic application context container. BeanFactory and related interfaces, such as BeanFactory Aware, Initializing Bin, Disposable Bin, are important integration points for other framework components. By not requiring any annotations or even reflection, they allow for very efficient interaction between the container and its components. Application-level beans may use the same callback interfaces but typically prefer declarative dependency injection instead, either through annotations or through programmatic configuration. Note that the core BeanFactory API level and its default listable BeanFactory implementation do not make assumptions about the configuration format or any component annotations to be used. All of these flavors come in through extensions, such as XML bin definition reader and auto-wired annotation bin post-processor, and operate on shared bin definition objects as a core metadata representation. This is the essence of what makes Spring's container so flexible and extensible. BeanFactory or application context. This section explains the differences between the BeanFactory and ApplicationContext container levels and the implications on bootstrapping. You should use an ApplicationContext unless you have a good reason for not doing so, with generic ApplicationContext and its subclass annotation config ApplicationContext as the common implementations for custom bootstrapping. These are the primary entry points to Spring's core container for all common purposes: loading of configuration files, triggering a class path scan, programmatically registering bin definitions and annotated classes, and, as of 5.0, registering functional bin definitions. Because an application context includes all the functionality of a BeanFactory, it is generally recommended over a plain BeanFactory, except for scenarios where full control over bin processing is needed. Within an application context, such as the generic application context implementation, several kinds of beans are detected by convention, that is, by bin name or by bin type in particular, post-processors, while a plain default listable BeanFactory is agnostic about any special beans. For many extended container features, such as annotation processing and AOC proxying, the bin post-processor extension point is essential. If you use only a plain default listable BeanFactory, such post-processors do not get detected and activated by default. This situation could be confusing, because nothing is actually wrong with your bin configuration. Rather, in such a scenario, the container needs to be fully bootstrapped through additional setup. The following table lists features provided by the BeanFactory and ApplicationContext interfaces and implementations. Bin instantiations/wiring. Yes. Yes. Integrated lifecycle management. No. Yes. Automatic bin post-processor registration. No. Yes. Automatic BeanFactory post-processor registration. No. Yes. Convenient message source access for internationalization. No. Yes. Built-in application event publication mechanism. No. Yes. To explicitly register a bin post-processor with a default listable BeanFactory, you need to programmatically call add bin post-processor, as the following example shows. Default listable BeanFactory factory equals new default listable BeanFactory, / populate the factory with bin definitions, / now register any needed bin post-processor instances. Factory.add bin post-processor new auto-wired annotation bin post-processor, factory.add bin post-processor new my, bin, post-processor. / now start using the factory. To apply a BeanFactory post-processor to a plain default listable BeanFactory, you need to call its post-process BeanFactory method, as the following example shows. Default listable BeanFactory factory equals new default listable BeanFactory, XML bin definition reader equals new XML bin definition reader factory, reader.load bin definitions new file system resource beans.xml. / bring in some property values from a properties file. Property sources placeholder configurer CFG equals new property sources placeholder configurer, cfg.set location new file system resource jdbc.properties. / now actually do the replacement. cfg.postprocess BeanFactory factory. In both cases, the explicit registration steps are inconvenient, which is why the various application context variants are preferred over a plain default listable BeanFactory and Spring-backed applications, especially when relying on BeanFactory post-processor and bin post-processor instances for extended container functionality in a typical enterprise setup. An annotation config application context has all common annotation post-processors registered and may bring in additional processors underneath the covers through configuration annotations, such as at enable transaction management. At the abstraction level of Spring's annotation-based configuration model, the notion of bin post processors becomes a mere internal container detail.